Now we're going to look at some word problems that involve exponential equations. So the graphs of y equals 2 to the 3x and y equals 3 to the x plus 1 intersect at approximately 1.1201, 10.2692. What is the solution of 2 to the 3x equals 3 to the x plus 1? Now remember, if we have two graphs and we graph them on the same plane, the point or points that they intersect at is going to be where they're equal to each other. So we can set the two equations equal to each other, like they have done for us here, and then we're going to solve for x. So because I have my exponentials, I'm going to take the log of both sides first. So I'm going to do the log of 2 to the 3x equals log of 3 to the x plus 1. Since I have logs, I'm going to bring my exponents down in front. So I end up with 3x log 2 equals x plus 1 log 3. Okay, so what we're trying to do now is get the x by itself. Now there's x's on both sides, but we want to get at least one of the x's kind of alone right now. So we're going to use decimals for these, so we're going to use the calculator. So if I'm going to get the x alone, I'm going to divide this side by 3 log 2. What I'm also going to do is I'm going to divide this side by 3 log 2. And if you notice, I'm only dividing the log 3 by the 3 log 2, not the x plus 1. So what I'm going to end up with is x on the left, and then I'm going to have x plus 1, and then I'm actually going to do log 3 divided by 3 log 2 in the calculator to get a decimal. So this is going to give me 0.528. So what I'm doing now is I'm distributing that 0.528 to both. So I end up with 0.528x plus 0.528. So now I can bring my x's together. So I'm going to subtract the 0.528x. So I get the x on one side. So I'm going to have 0.472x equals 0.528. And now if I divide both sides by 0.472, I'm going to get that x equals 1.119. And if you look, that is very close to the x value that they gave us, 1.1201. So because of rounding purposes, it's slightly off, but that would be my solution. So I can solve it graphically by graphing the two and seeing where they intersect, or I can set them equal to each other, solve for x, and then if I plugged x back in for the y, I would get in this case y is about 10.25, which is going to be a little off because of the rounding. So my solution is the same as my graphed solution. Now if we look at the second example, so you have the formula P equals P of 0 of 1/2 to the H over 4795. P is the atmospheric pressure in millimeters of mercury at elevation H, meters above sea level. P sub 0 is the atmospheric pressure at sea level. P sub 0 equals 260 millimeters. At what elevation is the pressure 42 millimeters? So they're throwing a lot of things out at you with this question. So basically what we're trying to do is just fill in stuff that we know. So the P is the pressure. So we're trying to find when the pressure is 42. So we're going to plug in 42 in for the P, regular P. Now P sub 0, it tells you, is 760. So we're going to put 760 in. We're going to leave the 1/2 as 1/2. We're trying to solve for H. So I'm going to keep the H as H, and then we have 4795. So we have the exact formula. We're just plugged in everything that we know, and the only thing we don't know is the H, and that's what we're trying to solve for. So from here, we're going to try to get that H by itself. So first thing we're going to do is let's get rid of that 760. So I'm going to divide out this 760. What I'm trying to do is get the base. In this case, the base is the 1/2, because it's being raised to a power. I'm trying to get that by itself, the base and the power. So I'm going to divide by 760, and again, we can use a calculator. So 42 divided by 760 is going to give us 0.0553. And again, it might be slightly off because of rounding, but we want to be kind of as exact as possible. That's why I have 4 decimal places here. So this is going to be equal to 1/2 to the h over 4795. Okay, so all we did was get rid of the 760, so we got the base by itself. So now that I have the base by itself, I'm going to take the log of both sides. So what I'm going to do is I'm going to do log of 0.0553 equals log 1/2 of h over 4795. Now when we take the log of each side, we're going to bring down the exponents. Okay, so the left side is going to stay log of 0.0553. And now the right side, I'm going to rewrite it as h over 4795 in front. And then I have log 1/2. So I'm trying to get the h over 4795 by itself. So I'm going to divide log of 1/2. Okay, so that's gone. And then again, we'll use a calculator to do log of 0.0553 divided by log of 1/2. So what we end up with is 4.1775, and that's equal to h over 4795. So now what we're trying to do is just get h by itself. So we're going to multiply both sides by 4795. So then we end up with h, and h is equal to 20,031.3 meters. Another example is when you have one of the problems that we've seen from the applications lesson, where we normally would use the table of values to find what t equals after we know the amount of money. But now we can solve it. So suppose you deposit $2,500 in a savings account that pays you 5% interest per year. So for part A, how many years will it take for you to double your money? So we could write our equation, put it in the calculator for y equals, hit that second graph and look at the table of values for where it was double the money, or $5,000. Or we can solve it. So you have to know how to solve it, because on a test or quiz, I'm going to ask you for the equation. I'm going to ask you to solve it by hand as well. So you can use the calculator to double check, but you have to know how to set it up and solve it. So for part A, first we're going to write our equation. So we have A of t equals the initial amount, which is 2,500, 1 plus, because since it's a growth, you're gaining interest, so it's 1 plus the rate. The rate is going to be 0.05 to the t. So we know the amount after time t. We want it to be double our money. So instead of A of t, I'm going to put in 5,000. And I'm going to keep everything else the same and just smush that together. So now we're going to solve this. So in order to solve this, first thing I want to do is I want to isolate the base to the exponent. So I want to get rid of the 2,500 first. So I'm going to divide by 2,500 on both sides. So 5,000 divided by 2,500 is just going to give me 2. That's gone. So now I have 1.05 to the t. So now that I have the base to the exponent, I'm going to go ahead and take the log of both sides. So this is going to be log of 2 equals log of 1.05 to the t. And because of that rule, I can bring that exponent down. So log 2 is staying on the left, and this is going to be t log of 1.05. So to get t by itself, I'm going to divide by log 1.05. And then we can just plug this into the calculator, and we can get t. So t is going to be, in this case, 14.21. And we're going to round it up, and we're going to say about 15 years. Okay, so if it's past a number, you're going to round up to the next whole year. Okay, so I'm just going to do this so we can do part B over here. So now B is the same idea, but how many years is it going to take for your account to reach 8,000? So now we're going to plug in 8,000 as your A of t, and you have 2,500 times 1.05 to the t. So now again, isolate the base to the exponent, so we're going to divide out the 2,500. So 8,000 divided by 2,500 is going to give me 3.2. And then we have 1.05 to the t. Okay, so now we're going to take the log of both sides. So I'm just going to kind of skip a step and just say log of 3.2 equals t log of 1.05. So I'm combining two steps in one. I'm taking the log and I'm bringing the exponent down. So I'm going to divide both sides by log of 1.05. And then we'll get that t equals 23.84. So we're going to round it up, and we're going to say about 24 years.